differentiate the following functions with respect to x. So in last class, I explained about logarithms, their formulas. Am I right? Everyone should remember logarithmic formulas and its graphical representation. Okay, not compulsory, but anyhow, if you have idea, it is better. So here in graphical representation of exponential also, see here, for 2 power x, we are going to get the graph like this. It will be move to, like it almost very near to y-axis, tends to minus infinity. It will tends to minus infinity. So near to x-axis, sorry, it is near to x-axis. But it cannot be touch the x-axis. It almost near to x-axis. The graph near to x-axis when x tends to minus infinity. So when here 2 power x, 2 is clearly greater than 1. When I take the function 1 by 2 whole to the power of x here, what is the a value? It is in the form of a power x here. A is lesser than 1. Yes or no? 1 by 2 is lesser than 1. So there are two types of graphs will be there. One is greater than 1. One is lesser than 1. Whenever it is lesser than 1, the graph of the given functions we are going to get like this. That is also even 1 by 2 whole to the power of x also passing through this point. This is common point to any function. Like it may be 100 power x, 1000 power x also, it is passing through 0, 1. It is 1 by 2 whole power x or 1 by 200 whole power x, 1 by 2000 whole power x, whatever it is, that is also always passing through 0, 1. Any curve, you can take any exponential function, even e power x also. Every function is passing through 0, 1. So what is the graph of 1 by 2 whole power x? Almost we are going to get like this. So the curve is moved towards when x tends to plus infinity, the graph of the given curve is almost going to meet the x-axis. Do not touch that x-axis, but it is very near to x-axis. These are the graphs. So this is the graph of 1 by 2 whole power x. This is the graph of 2 power x. Remember, every exponential must be passing through 0, 1. Okay, that is this exercise is the logarithmic concept belongs to next exercise 5.5. But here simply in this all the questions we can use only 3 formulas. We can use only 3 formulas. First one is product rule, remember. Second one is quotient rule, remember u by v. And third one is chain rule. Chain rule. So division rule or quotient rule, u by v, derivative of u by v, derivative of uv, and with the help of chain rule. So this is, in this problem you can apply u by v, in first problem you can apply u by v. Okay, so remaining almost all the questions we are going to use chain rule alone. Chain rule, that's it. First question, y is equal to, the first question is, let us consider y is equal to e power x by sin x. Yeah, e power x by sin x, differentiate with respect to x. Let us take this is equation 1, and this is also you can comparing with u by v. This is in the form of u by v. So where u is equal to e power x, which implies u dash is also e power x. The derivative of e power x is e power x. V is sin x, which implies p dash, nothing but dv by dx is cos x. Since we know that the derivative of u by v is equal to v u dash minus 2v dash by v square. Am I right? So substitute all the values Okay, all the values here. Now, and also you have to write differentiate equation 1 with respect to x on both sides. Okay, students. Now, when we differentiate with respect to x on both sides, already left side we will get dy by dx. Right side, v u dash. What is v? Sin x. Into u dash value is e power x only. Minus u nothing but e power x. V dash means already here, v dash is cos x. A simple question by v square, that is sin x the whole square. Got it? Is there any common in numerator? Any common? E power x is common. Sin x minus cos x all divided by sin x the whole square. This is the derivative of the given function e power x by sin x. Any doubts? I used your quotient rule, u by v formula. First given function comparing with y is equal to u by v. You will get u and v, then u dash, v dash. Substitute all values in standard form. Second one is very easy. We can use chain rule. E to the power of sin inverse x. Again same. Let us consider the given function is as y e to the power of sin inverse x. Right. Again, this is equation 1. What to do? Same. Differentiate with respect to x on both sides by using chain rule. Chain rule. Okay, students. So left side obviously dy by dx. Right side is d by dx of e to the power of sin inverse x. Since it is in the form of formula d by dx of e power x. What is e power x derivative? E power x. So in the same way, e power sin inverse x derivatives e to the power of sin inverse x. Okay, I said clearly we can apply chain rule. Okay, e to the power of e derivative completed. Next sin inverse x is there. So d by dx of sin inverse x. Now e to the power of sin inverse x. What is the derivative of sin inverse x? 1 by, yes, the bracket, since you have to write like this, d by dx of sin inverse x is equal to what? Students, 1 by
root over 1 minus x square.
That's it. Root over 1 minus x. Got it? So this is the answer. Finally, the answer is e power sin x by root over 1 minus x. Upon 1 minus x. This is the required dy by dx. Clear, students? Next, question number 3. Question number 3, you can try. The answer is 3x squared. I'm going to do question number 4. Question number 4 is y is equal to sine of tan inverse of e to the power of minus x. Again, let us take this is equation 1. Equation 1. So here with the help of, okay, what is the formula here applicable? UV formula or UVW or else U by V or chain rule? What is the rule you want to use here? Yes. How many functions are there here? Is it we having only single function or else
3.
No, no, no. Here only we are having single function, that is sine, tan, e power x. Only single variable. It is not the product of two different functions. Okay, single function. But whenever we want to differentiate, we can differentiate thrice. That is sine separate, tan inverse separate, e power separate, like e power x with the help of chain rule. Okay, same. Differentiate equation 1 with respect to x on both sides by chain rule. Now left side is clearly dy by dx, right side d by dx of given function you can write here. Then d by dx of sine. First the derivative of sine becomes cos. Sine becomes cos, remaining function as it is. Okay, sine derivative completed. Next what? Tan inverse. Okay, next we need to differentiate tan inverse. So that d by dx of tan inverse e to the power of minus x. And it's better to you have to write since d by dx of sine x is cos x, like that. Okay, now here tan inverse x is there, since again the derivative of tan inverse x is equal to 1 by 1 plus x square. So in place of x here we are having e power minus x, but anyhow, so this is equal to cos of tan inverse of e to the power of minus x of, yeah, now derivative of tan inverse is 1 by 1 plus x square. What is x value here in place of x? Yes,
e power minus 6.
e power minus x the whole square into, okay, we differentiated even tan also from equation 1. What is the remaining function? E to the power of minus x. So d by dx of e to the power of minus x. Now, so this is equal to cos of tan inverse of e to the power of minus x whole divided by 1 plus e to the power of c. E to the power of minus x whole square, shall I write like e power minus 2x? Now, e to the power of minus x is what, student? Actually, we can write like this. E power minus x into again d by dx of minus x. Again, chain rule. See, I differentiated next to tan. Next after that, minus x is there. Plus x is plus 1, minus x becomes minus 1. Finally, therefore, dy by dx becomes, what is the derivative of minus x? Yes, minus 1. That minus you can take outside. Then finally, I'm going to write minus e to the power of minus x cos of tan inverse of e to the power of minus x whole divided by 1 plus e to the power of minus x. Having any doubts, students? What I have done with the help of chain rule, first I differentiated sine, then I differentiated tan inverse, then I differentiated e power minus x. Then after I return one more step, that is d by dx of minus x. It's minus. If you have any doubts, you can ask. This exercise having very easy problems. So what about this question number 5, 6, 7? Okay. Okay, students, that this slide I am going to share you in our Google Classroom. You can go through that.
Can you scroll down, sir?
One second. Here,
Negative, sir.
Yeah. Next, students, can you do that remaining problem? Can you try? Your chain rule. Here also chain rule. I think so. We completed already these remaining questions. Am I right? I think you have
So can I do 7th problem or not, sir?
7th. Okay, fine. Seventh one is let y is equal to square root of e to the power of
Root x.
root x. Here domain is what? X greater than
Greater.
1. Otherwise it is imaginary, right? This is equation 1. Now differentiate same. Differentiate 1 with respect to x by chain rule. Okay, here left side is d by dx, right side is d by dx of square root of e to the power of root x. Okay, since first, here how many times we need to differentiate? First we can do the square root, next e, then next square root. 3 times we need to differentiate. First whole square root is there, right? Whole to the power of 1 by 2. So since we know that the derivative of d by dx of root x is what, student? 1 by 2 root x. It is in the form of root x. In place of x here we have e to the power of root x. Okay, that is second. So apply that formula here. We get 1 by 2 root e to the power of root x. Okay, fine. Root x derivative completed. Root square root. Next e to the power of root x derivative, that is d by dx of e power root x. Step by step. This is called a chain rule. Now, since we know that again, it is in the form of d by dx of e power x is e power x. Apply this formula, so we are going to get 1 by 2 root e to the power of root x.
Sir, negative 1 by 2 root, no, sir. Negative
Yes.
sign number.
Negative sign.
The derivative of root x, sir.
1 by 2 root x. Sir.
Minus will come, no, sir. N
No.
into minus 1.
No.
X power n minus 1, no, sir.
Yeah, I'll explain. You can see. I think so. Already explained once again. Look at it. D by dx of root x. Okay, students. D by dx of root x. D by dx of root x means x power 1 by 2. Am I right?
Yes, sir.
Root x. X power n formula is what? X power n derivative. N into?
X power n minus 1.
Okay.
Yes, sir.
1 by 2. X power 1 by 2 minus 1 is?
Yes, sir. Yes, sir.
Understood? Huh?
Yes, sir.
This can be written as 1 by 2 times of x power 1 by 2. Because negative, power is negative, take into denominator, so 1 by, then again x power 1 by 2 can be written as 1 by 2 root x. Okay. Remember that formula, root x directly. Okay, so it is in the form of e to the power of x, so e power x again into, students,
P root x.
d by dx of root x. So e to the power of root x by 2 times of root over e to the power of root x into, now root x derivative again 1 by 2 root x. Just now I derived that. Okay. So finally, what is the answer? Therefore, dy by dx is equal to 1 by, e to the power of root x by 4 times of root x into, when you take root x is inside, accelerate at a time. So root is common, square root is common, so that square root of x into e to the power of root x. Okay, if you want to cancel, see this is also can be written. Shall I write this numerator as again whole square root of whole square? Shall I write like that?
Yes, sir.
Yeah, see here. In denominator also, shall I write it separately, right? Shall I cancel this 2? Finally, we are going to get square root of e to the power of x by root x. That is, we can write 1 by 4 times of x. We can write many ways. If we write up to here also, that is also correct. Or else after simplifying, we are going to get 1 by 4 times of square root of e to the power of root x by x. That's it. This is the answer. So the last step, don't be confusing, easy only, right? Square root is there without square root. I written square root of whole square, then one get cancelled, remaining value is square root is common for numerator and denominator, 1 by 4 times of square root of this one. Is it clear, students? Any doubt?
No, sir.
Sir,
Yeah.
can I do the 10th question also, sir?
Let us do the 10th question. Yes, Amma, you want the 10th question?
Yes, sir.
Right. 10th question is what? Cos of y is equal to cos of log x plus e power x. Right. Now, see here. Here also we can apply chain rule, not product rule. It is only unique function. Cos of, not cos x into log x plus e power x. Okay. Even you should not write separately also. When you can write separately, if you apply log a plus b formula, that is not required now. So when I differentiate with respect to x here, dy by dx is equal to d by dx of given function. Cos of log x plus e power x. So here, now, change with the help of chain rule, first you can differentiate cos. When you differentiate cos, cos becomes minus sign of bracket value as it is log x plus e power x. Sign in place of sign, just write minus. In place of cos, just write minus sign. Then now the derivative of bracket value, step by step. You have to differentiate from left side onwards, right? So remaining log x plus e power x. So minus sign of log x plus e power x into, what is the log x derivative? 1 by x. Okay. What is the log x derivative? 1 by x plus e power x is e power x. This is the answer. Okay, students. Even if you want to take LCM, you can take LCM. When you take LCM, here 1 plus e power x will get. So here minus is common. So minus. It's better to write this first, 1 plus x e power x whole divided by x and taking LCM. Now sign of log x plus e power x. Yeah. What about others? Anyone? Any question down?
So, sixth question. Sir.
Sixth one. Okay. Y is equal to e power x plus e power x square plus so on e power x for 5 they given. And consider that value as y. Now dy by dx. differentiate this equation 1 with respect to x on both sides. D by dx of e power x plus e power x square plus e power x cubed plus e power x power 4 till they given e power x power 5. And right now, apply the multiply this d by dx to each function. Write it separately. D by dx of e power x square plus d by dx of e power x cubed plus d by dx of e power x power 4 plus d by dx of e power x power 5. Right? I apply the derivative to each and every function. Now, the derivative of e power x is e power x. Then what is the derivative of e power x square? Is e power x square again the d by dx of x square. Like that, you have to write the steps. E power x cube is e power x cube, again d by dx of x cube. E power x power 4 is e power x power 4, again the derivative of x power 4. This e power x power 5 is e power x 5, d by dx of x power 5. Understood? Chain rule. First e, then the derivative of its power. Finally, it is equal to dy by dx is equal to therefore the power, like the derivative is equal to e power x. Yeah, student, can you tell me what is the x square derivative?
2x.
2x.
2x into e power x square. Then x cube derivative
3x square.
into e power x cube. X power 4. X power 4 is 4x cube into e power x power 4. Finally, x power 5 derivative 5x power 4 e power x power 5 with the help of x power in form. So here itself it's better to write like this also, since d by dx of x power n is n x power n minus. So this is the formula only we used here to get x cube derivative x square x power 4 x power 5. So this is the answer. Any other questions? Note it down. Students, if you're having like any doubts, now itself you can ask. Okay. So if you're not asking any doubts, I thought that everyone is understood. I think so everyone is understood. So in case if anyone is not understood, you can ask. Then this is, let's go for the next exercise. Logarithmic differentiation. Logarithmic differentiation, I'm going to explain you in what cases we will apply the logarithmic differentiation. Logarithmic differentiation in the sense, take log on both sides, logarithm on both sides. Apply logarithm on both sides. That's it. So logarithms differentiation. Differentiation. Clear, students? Right. So when the function here, this method is used by when the function is in the form of, for example, y is equal to something like fx whole to the power of g of x. Function power function, you can use logarithmic function. And y is equal to fx by gx. Function by function, you can apply logarithm. And y is equal to like this, fx power fx or fx or till infinite terms, infinity times, fx power fx power fx power, apply logarithm infinite times. And the function in the form of like f1x into f2x, f1x into f2x into f3x, okay, so on. f1x product of different functions, f3x, so on, fnx. Okay, the product of different functions, then we can apply the logarithm on both sides. So how many cases I can explain you, like first, second, third, this is fourth and fifth. Not only this, the function in the form of the y is equal to same f1x, f2y, f2x, so on, fnx by all divided by g1x, g2x, so on, gn of x. Okay, like a function by product of functions by product of functions. In that case also we can use logarithm. Sixth one, y is equal to root fx plus square root of root fx plus square root of root fx plus so on till up to infinite terms. In that case also we can apply logarithm. Okay, so these kind of questions we don't have anyhow. You should have some idea about that. In what cases we can apply log on both sides. Function for function, function by function, function for function, function like that up to infinite terms. Function product of some finite number of functions, and product of functions by product of functions, and square root of infinite functions. These cases you can apply logarithms. And remember here one more point, a function for function for function, it must be up to infinite, then only logarithmic method will get the answer. It should be infinite. It should be finite again. We may not be apply that logarithm. Here also same square root of square root of square root of up to infinite. Then only we'll get the answer. If it is square root of square root of square root of some finite values, again same, we cannot. And also here sign, it may be plus or minus, plus or minus, plus or minus. Either it might be all or plus, all or minus, we can apply the logarithms. When you see the exercise questions, not this much difficult. Yeah. See, product of function f1x, f2x, f3x. That's it. Here, product of functions by product of functions. Function for functions. That I already explained in last class. Okay, let's do the problems. I'm going to do first question. Exercise 5.5, first question. So again, same here also, let us consider the given function as y. First one, cos x, cos 2x, cos 2x, cos 3x. I said very clearly, I don't know how many of you remember. We can apply UV formula also. Y is equal to UV formula also, you can apply, you get the answer. That not required. So I'm going to apply logarithm conversion. Logarithm on both sides of equation 1. Okay, apply logarithmic on both sides, taking log on both sides, like that you can write. Then left side is log y is equal to right side is log of cos x, cos 2x, cos 3x. Am I right, students? Right. See, this is in the form of, what do you observe here? This is in the form of what formula? Since this is in the right hand, RHS is in the form of ABC, log ABC. What is log ABC formula? Log A plus log B plus log C. Am I right, students? Apply this formula. So we are going to get log y is equal to log A. So log of cos x plus log of log B. So this is, I'm taking as A, B, C. Log A, B, C. Log B, that is cos 2x is log cos 3x. Now you can let us take this is equation. First I'm applying a log on both sides. Then we got equation 2. Then now we can differentiate. Differentiate equation 2 with respect to x.
So you can scroll up a little.
Since we know that anyone can say what is the derivative of log x. Derivative of d by dx of log x.
1 by x.
1 by x.
1 by x. Apply this property here. So all are logarithmic functions only. 1 by x. Log y is 1 by y. That's it. With respect to x we are doing. What about log y derivative? 1 by y. Is that
dy by dx.
into dy by dx? Well, don't be forget, because with respect to x, y is independent. So dy by dx will get, okay. Now log. So in place of x cos x is that log x derivative 1 by cos x. Again the derivative of, if you want to write more number of steps, again you have to write. Yeah, you have to write like this. Then plus log cos 2x 1 by cos 2x into d by dx of cos 2x plus log cos 3x 1 by cos 3x into d by dx of cos 3x. See, now write it. See here, we required only dy by dx. We don't want to y. Y you can take right side. Dy by dx is equal to y. Right. What is the derivative of cos x? Cos x derivative. Can I write minus sin x? Is cos x derivative?
Yes, sir.
By cos x plus 1 by cos 2x into cos 2x derivative minus sin 2x into derivative of 2x, that is 2. 1 by cos 3x. The derivative of cos 3x is minus sin 3x into 3x derivative is 3. Because x derivative 1. 3 into 1, 3. Finally, we got this. Now student, what is the LCM here? I am going to take LCM. I want to take as LCM. LCM. Y times of. What is LCM? Can anyone tell that? Cos x, cos 2x, cos 3. Okay, and also once can you see that book back answer whether they have taken LCM or else they did not take any LCM? What is the answer they given?
In the form of tan they give.
Okay, then tan nothing but no need to take LCM. Look at it. You have to substitute y. What is y? Y nothing but given question. What is the question? Cos x, cos 2x, cos 3x. And what is the common in all the functions? Minus is common. Minus, take it outside. Then now, sin by cos is tan x. Sin 2x by, that is 2 tan 2x. Then 3. 3 times of tan 3x. This is the required dy by dx. Then. Okay.